Submerging.
Behind each run is weeks, sometimes months, of design, testing, and iteration. Now this is what it takes.
This year, Mechanicals focused a lot on working on Crush. One big thing we did on Crush was adding 8 thrusters from 6. 8 thrusters enabled pitch control on the robot, which greatly improved the controllability for our CS team. The next big thing we worked on for Crush was optimizing its hydrodynamics. We did CFD, or computational fluid dynamics, to show that the improvements would actually optimize forward movement. For our new buoyancy blocks, we custom CNC machined 3-dimensional shapes so they fit perfectly inside of our robot. One thing we noticed after our first year using Crush is that we would keep hitting the sonar on the wall. This year we worked to improve that, and now the sonar will no longer be able to physically hit the wall. One last thing we did on Crush was add a marker dropper this year. For Oogway, a big focus this year has just been improving reliability. For this, we've redesigned the battery capsule. We've also made the size of torpedoes much smaller while maintaining the same functionality. We've started work on a robotic gripper.
We've built multiple prototypes to make it as simple as possible for our CV team to identify an object and grab it.
In the electrical sub-team, we replaced Crush's servo driver for dependability and because we added new servos and thrusters. Our acoustics team has been developing a system that filters and amplifies signals from the underwater pinger. Looking ahead to RoboSub 2027, we're currently developing a complete redesign of our electrical system. Right now, we use jumper wires and separate integrated circuits, but we're replacing that with a printed circuit board stack. This change will reduce our electrical stack size by about 20%. And it would also make the system fully modular since each board will be plug and play. Debugging will also become much easier and reliability will improve significantly.
This year, we have completed reliable sonar integration. By analyzing sonar scans, this will allow us to detect objects and improve the accuracy of our positioning underwater relative to these objects. We have rewritten our yaw and move to CV object. Previously, our algorithms operated on a series of abrupt movement steps. With this new improvement, the robot will adjust speed based on measurements from the cameras. As we look forward to building a new robot next year, we have been benchmarking our Jetson Nano computer with various YOLO models. This allows us to plan new hardware and move away from our current depth AI camera reliance, increasing flexibility in our code and electrical stack.